Di era awal
Welcome back. We can have more than one instance of a class, and each one will have its own attributes, its own internal state. In this code, we'll create two turtles, Alex and Tess. Tess is going to draw a triangle with a thick black pen. Alex will draw a square with a pink pen. So let's go through the code. First, we'll run it. That's Tess drawing there, and now Alex is drawing. So let's go through the code. As before, we need to import the turtle module and create the screen. That creates the place for us to do the drawings. In this case, we get that instance bound to the variable wn, and we're calling the bgcolor method on it to make it be light green, as you're seeing here. We create a turtle Tess, and we set its pen size to be 5. That's what makes Tess have this wider pen instead of just the narrow pen that's the default. We create a second turtle called Alex, and we set Alex's color to be hot pink. After that, we have a whole segment where we have the movement commands for Tess. That's where she does her drawing. And then below that, we have some movement commands for Alex. And finally, there's this little wn.exit on click. That just says that when somebody clicks on the window, it disappears. Let me make a couple comments about the coding style here. One thing to notice is that we've chunked the code using some white space. And that just makes it easier to read. That segment that I just marked, lines 12 to 17, is what causes Tess to make her triangle. And then there's a break with a blank line on line 18, and then lines 19 and 20 have her make her extra line that goes off to the left at the end of the drawing. Then there's another blank space, and we get from lines 22 to 29 Alex's movements. We don't have to do this chunking in order to make the picture come out right. We do this chunking because it makes it easier for people to read the programs. You can sort of look at it and say, oh, there's a chunk of code from 22 to 29, and that's drawing a square. There's a chunk of code from 12 to 17, and that's drawing a triangle. One final thing to notice, and I'm going to rerun this so that you'll get to see it again. You might notice that on line 17, Tess turns to the left by 120 degrees. Then on line 19, she turns to the right by 180 degrees. We're following a little convention that lines 12 to 17 are drawing a triangle and putting Tess back into the same orientation that she started in. It just makes it easier for a programmer to think about it if the net impact of all of the movements is to leave Tess back in her original position in the same orientation. Similarly, on line 29, you'll see that after we've completed the square, we make Alex turn to the left for 90 degrees, even though we're not going to make him move again. And that's, again, just trying to get him back into the same orientation he was in before. This would be especially useful if we were going to take the whole block of code and reuse it. And that's something that we'll see later in the course where we define functions. We could make a function to draw a square, and wherever he starts, the turtle would create that square and leave the turtle in the same spot that he was in before. So let's go on and do one of the Parsons problems. At the bottom of this page, you'll find more than one Parsons problem. I'm just going to go through one of them. Here, we're going to create a program that has one turtle, Jamal, draw that capital L in blue, and then Tina is going to draw that orange line. So this is a mixed up code problem. We have all of the code that we need to have Jamal draw his blue L and Tina draw her orange, but your job is to drag the parts over and drop them off in the right order. The first thing to remember about this is that the very first thing in any turtle program is you have to import the turtle module so that we can have all of those turtle commands available. And you have to create an instance of the screen so that there's a place for the turtles to draw. In the instructions, it said that all the stuff with Jamal should happen first. So those things are going to come before the Tina stuff. But we do have a little decision to make. Should we make the left and the forward commands first, or should we have this larger block first? And the clue here is that you can't have Jamal turn left before you create Jamal. So we need to have this block first because it has the line of code Jamal equals turtle.turtle that creates the instance Jamal. Tina's stuff happens after Jamal. Oops, got to get that a little lower. And finally, we have our exit on click so that when the user clicks on the drawing, it disappears. Let's check it and make sure I got it right. Perfect. All right, see you next time. Suppose we have a line of code or a bunch of lines of code that we'd like to make run more than once. You could just write those lines of code and copy and paste them so that you had them again. But that would start to give you long programs that were hard to understand. So Python gives us a special command that says, do some lines of code multiple times. It's called a for loop, or iteration. We begin with a special word, for. Then we have some variable name, or in this case, since we're not really using it, we just have underscore. And we have a special word, in. And in this case, we say, do it 3 times. And then we have a colon. All of the lines of code that are indented farther in this case by a few spaces, all of those lines of code are a block, and that block of code will be executed 3 times in this case. It's always a good idea to work on your understanding of code before you run it to try to predict what it'll do. In this case, you might imagine that it's going to print in our output window, this will execute first, and then it'll say this will execute 3 times, this line will execute 3 times, this line will will execute 3 times. And then this line will also execute 3 times. This line will also execute 3 times. But in fact, it doesn't do that. It doesn't print this line 3 times and then this one 3 times. What it does is it executes line 4 and then line 5, and then 4 and then 5, and then 4 and then 5. So the whole block is executed, and then the whole block is executed again, and the whole block is executed a third time. Let's see how that works. So you can see in our output window, the whole block executes once, and the whole block executes a second time, and the whole block executes a third time. Let's go look at the next example. In this next example, we're going to be able to draw a more interesting turtle program by having a set of commands get executed a bunch of times. In this case, we're creating a turtle named Elan, and we're going to make Elan do some commands 10 times. For underscore in range of 10, do this block from lines 8 through 10, do that 10 times. So Elan's going to go forward by 50 and then turn right 90. Remember from the previous chapter what distance equals distance plus 10 does. We had the variable distance, and it was initially bound to the value 50. We look up 50 plus 10, that equals 60, and we replace the 50 with 60. The next time that we execute line 10, we're going to replace it with 70. And you can see that that distance variable is used here to determine how far Elan will move. So each time Elan moves forward, he's going to go forward a little bit farther. 50 pixels the first time, then 60, then 70. So before I run this, you might want to pause the recording and see if you can envision in your mind, what is this going to look like when I run it. Here we go, let's see. So it's getting a little bit longer each time, and that means instead of just making a square, it ends up making a spiral. So how many times does it do this block? It does it 10 times because it says range of 10 there. Now what if I made the angle increase every time too? Suppose instead of turning right by 90 degrees, I turned right by whatever the current value of the angle was, and it started at 90. If I do this, I get just exactly the same picture that I have right now, but suppose that I change the angle every time. Maybe I'll make it a little bit smaller. So again, you might want to pause the video and see if you can predict what this is going to look like. Here we go. The angle's getting a little smaller each time, and so we end up with this even more interesting spiral. Now, if I wanted the spiral to go even farther, I could increase this range. Just means he's going to go forward and turn more times. He's a little off the screen there, and now he's back. And maybe he's gone forever now. So that's making the turtle do a set of commands a bunch of times so that we can have a relatively short program, but have it do a lot of drawing on the screen. Let's see a few more interesting things we can do with turtles. We've got another little spiral. In this case, we're not seeing the whole line. Tess is moving around and only leaving her imprint occasionally. So how did that happen? First, as before, we've seen things where Tess is getting a color, in this case blue. We also changed her shape. So instead of being that little abstract triangle representing a turtle, now Tess really looks like a turtle. On line 9, we introduced a new method called up. What that does is lift the pen up off the paper so that when Tess moves, she doesn't leave a line behind her. As before, we have a for loop. So 30 times we're going to execute that whole block of code. On line 11, we have a new method called stamp, which basically stamps Tess's shape at the current location where Tess is. And the rest of the things are things that you've seen before. He's moving forward. The distance is increasing a little bit each time. That's what makes it a spiral. In this page in the textbook, there are some more mixed up code problems, Parsons problems, and I really encourage you to take a look at those because they will help you reinforce what order these things have to happen in, and the fact that you have to indent the block of code under the line that says for. See you next time.
Tahun 2000-an, semua stigma positif yang telah ia bangun akhirnya hilang tak bersisa. Pak Mario Teguh ini memiliki seorang anak laki-laki dari pernikahan. Saya tidak memiliki anak selain sebuah foto dengan caption, "Ini adalah keluarga Mario Teguh." Audrey adalah anak pertama saya dan Marco adalah anak kedua saya. Saya tidak memiliki anak selain kedua anak muda itu. Di mana faktanya, Pak Mario Teguh ini memiliki seorang anak laki-laki dari pernikahannya dengan Ibu Aryani Sunarto. Lantas berdasarkan postingan Pak Mario Teguh inilah membuat Aryo Kiswinar Teguh yang merupakan anak kandung dari pernikahannya dengan Ibu Aryani muncul untuk membantah postingan Pak Mario dan juga meminta Mario Teguh untuk meralat statementnya tersebut.
Beliau post sesuatu di Instagramnya yang di captionnya itu salah satunya ya saya hanya punya 2 anak.
Mengakui anak kandungnya sendiri.
Terus ngangkat ke publik gitu. Yang udah dibiarin lah, maksudnya kenapa kok bisa segampang itu? Kamu bilang papa, aku anakmu.
Bahkan lebih parahnya lagi, Pak Mario Teguh ini menduga jika Ibu Aryani Sunarto telah berselingkuh dengan laki-laki lainnya.
Ini tidak menuduh bahwa Ibu Aryani punya hubungan dengan laki-laki lain, tetapi saya ini pecemburu. Jadi sering bertengkar kami tentang kecurigaan saya tentang kedekatannya dengan laki-laki lain. Pernikahan saya dulu
Welcome back. In all our turtle examples, I kind of glossed over the import statement. In this specialization, we're trying to minimize the amount of magic. We want you to be able to read code and reason about it. So this video provides some details about that import statement. There are lots of functions and methods available to you in Python that other people have already written, and we can just invoke them. We don't have to write them ourselves. Some of those functions are built into the core of Python, like the len function. You can just invoke it, and it's always there. Lots of other functions are not built into the core of Python, but are readily available. They're part of a standard library of modules. A module is a code file that defines some functions that can be used by other programs. Before you can invoke a function that's from a standard library module, you need to tell the Python interpreter to make it available, and that's what the import statement does. Turtle is one of those standard library modules, but we'll come back to that in a minute. Let's look at a simpler module first. There's a module called random, and you just have to import it in order to make all of its functions available. One of its functions is called randrange. You can see this on line 6. So we've imported the random module, and then on line 6 we ask for randrange, which says give me an integer between 1 up to but not including 7. So 1, 2, 3, 4, 5, or 6. There's another function called random, and I'll talk in a minute about this weird thing of random.random. We have this random function that returns a floating point number between 0 and 1. In this case, we got 0.72, and then we get a die roll, a 1, 2, 3, 4, 5, or 6 from the randrange function. If I do it again, I may get different values. Get 0.039 and 3. Run it a third time, I'll get yet again different values. There are two possible syntaxes for importing and referring to stuff from modules. The first makes the stuff available, but doesn't give it any special alias. That's what this version that I'm showing in the current code does. On line 1, we make everything from the random module available, but every time we want to refer to it, we have to say random dot. Random dot. It doesn't give us any alias. So I say random dot, and then the name of the function that's defined within the random module, like randrange or random. Notice that this is another use of the dot notation. Before, we've seen something like tess dot forward, where tess was a turtle object and dot forward, and we would say, how many pixels to go forward. Forward is a method that can be applied to test the turtle object. Here we're saying random.randrange. It's a little bit analogous. We're getting something from the random module, and that something is the randrange function. But it's not exactly the same. Random is a module, not the kind of Python object we've been seeing so far. The way to tell the difference between these two different uses of the dot notation is just by the context. If we said import random, as we did on line 1, then random.something will find the something object inside that module. Anyway, that explains the funny random.random on line 3. Random is the name of the module, so that gets us the first random. And inside that module, there's a definition of a function also called random. And that gives us the second random. Similarly, random.randrange, random is the name of the module, randrange is a function inside that module. The one thing we can't say is rand range dot random. That is going to fail. Don't do that. The second approach to importing stuff from other modules puts the function directly into our local namespace so we don't have to keep referring to the module they came from. Let me show you how that works. Instead of saying import random, we're going to say from random import rand range. And we can also import the random function while we're at it. Now when we refer to them, we no longer have to say what module they came from. Those names become available in our local namespace. And this will work just like the other one did. Module they came from, those names become available in our local namespace. And this will work just like the other one did. So we got a new value there when we ran it again. Either of these two different ways works. Either the commented out version that I have on line 1, import random, or the other version on line 2 from random, import, rand range, and random. But you have to refer to the things a little differently depending on which one you did. So if we say from random, import rand range, then we'll just refer to random. If we did the other one, we'll have to say random.random on line 4. With that understanding of module importing, let's take a look back at how we imported the turtle module. Let's look at lines 1 through 3 here. On line 1, we say import turtle, make everything from the turtle module available to us. And then on lines 2 and 3, we're doing that turtle dot thing. On line 2, we do turtle dot screen. Now we haven't explicitly talked about classes yet, and you won't talk about that until much later in the specialization. But this is creating a new instance of a class. The class capital screen is defined in the turtle module. Similarly, the class turtle is defined. So it's like we're invoking a function, but it's a function that creates a new turtle object. On line 2, it's creating a new screen object. So this is just an example of the same syntax we were seeing with import random previously. We're importing the turtle module, and then we're referring to something screen that is defined inside of the turtle module. By the way, we only have a few of the standard library modules that would normally be available in Python. Only a few of those are available in this Runestone textbook environment. We have the random module, the turtle module, and the math module, but there are a lot more that are part of the standard distribution if you just install Python on your own machine. They can do lots of stuff for you, so you don't have to write very much code yourself. You just have to find the right module. And then even beyond the standard library, there's lots of other modules that you can install if you've installed Python on your local machine. By the way, if you haven't seen XKCD before, there's lots of great geeky humor there, and I highly recommend it. Here's one of my favorites. A friend is talking to his other friend who's up in the sky. He says, "You're flying. How?" His friend says, "Python." which I hope you're also experiencing. You're using Python and you're flying high. He says, I learned it last night. Everything is so simple. Hello world is just print hello world. Of course, in the newer version of Python we have these days, we would have to have parentheses, but still very simple. And his friend says, I don't know about Python. I've heard it's got these weird things like dynamic typing and white space matters. And his friend who's up in the sky says, come join us. Programming is fun again. It's a whole new world up here. But how are you flying? Well, I just typed import anti-gravity. That's it? Well, I also sampled everything in the medicine cabinet for comparison, but I'm pretty sure it's the Python. So Python has lots of great modules. Just import them. I don't know about the anti-gravity module, though. We'll see you next time.
Class definitions or function definitions, or perhaps as class definitions that contain modules are files that contain Python elements such as class definitions or function definitions or perhaps special data items. But what a module allows you to do is to package up that functionality and then use it in any number of other programs. And so, for example, we've been using this module called Turtle. Turtle is provided to us as part of the standard library in Python, and when we import the Turtle module object, we've seen it a number of times, but what we need to know is that the import simply creates a name that refers to an object, much like a number of other things that occur in Python. So when we say import Turtle, what's happening is we're creating a name called Turtle, which is a reference to an object. But this object happens to be a module object. And inside that module object, there is a definition of a class called screen, and there is a definition of a class called capital T Turtle. And so by importing the Turtle module, the name Turtle now refers to this collection, and we can utilize these classes by simply saying, in the Turtle module, I would like to access the screen class and perhaps call the constructor. So the dot operator is used to connect the module name with an item that is in the module. So we've been using this as we've been doing Turtle programming. And Alex is a reference, but one is important for Python. If I click on that, I get import in get scrolling down what is the tool set that we can make use of.
Here is the new Lenovo ThinkPad T14S Gen 4, powered by the AMD Ryzen 7 Pro 7840U with 32GB DDR5 memory. Is it the best 14-inch business laptop out there? Review out soon. Here is the new Lenovo
As a reward for sticking around this far, here's a little joke. A snail was out on the beach taking a walk, and he looked back. He saw 3 turtles behind him wearing leather jackets. Made him a little worried, so he picked up his pace, and he's inching along. About 4 hours later, he turns around again, and sure enough, they're still following him, and they're getting closer. He's getting very worried, and he moves forward, keeps going. 2 hours later, he sneaks another look back. They're still following him, and they're really close. So he starts sprinting as fast as he can. But an hour later, the turtles caught him. They mugged him, took his money, his car keys, took him all the way till the next morning before he managed to get to the parking lot, to a payphone. He calls the police. He says, "I got mugged by 3 turtles wearing leather jackets. Can you get down here as fast as you can because they're going to get away?" The officer asks, "Sir, can you describe the turtles in a little more detail?" "No, I can't. It all happened too fast." Happy drawing. I'll see you for the next lesson. The parking lot, to a payphone. He calls the police. He says, "I got mugged by 3 turtles wearing leather jackets. Can you get down here as fast as you can because they're going to get away?" The officer asks, "Sir, can you describe the turtles in a little more?" Most weeks, our last lesson is going to be titled The Way of the Programmer. These segments are not about how Python works, but about how you should work. Style tips for your code, strategies for solving programming problems, habits, mindsets that'll make it so that you can have fun even though it's hard work and sometimes frustrating. This week, we'll focus on debugging. Your programs are not going to always work the first time. In fact, they rarely will. You have to debug them. And debugging your code is a little bit like being a detective in a crime movie where you are also the criminal because you wrote the code. So our learning objectives for this lesson, at the end of it, you should be able to distinguish between 3 types of errors: syntax errors, runtime errors, and semantic errors. You should develop a habit that when you get an error, you'll look at the error messages and you should start to build a skill of interpreting those error messages. You will internalize a mantra of get something working and keep it working. Don't write big swaths of code before you test it. And you'll be able to recognize some common errors and how to fix them.
Over the next 40 see why I believe fabric is such a transformational technology. Now, if you want to truly understand fabric, then there are some fundamental concepts that you will need to learn. So in part 2 of the course, we'll cover what I believe are the most important concepts that you need to understand, those being OneLake, the 7 experiences of fabric, and the 4 compute engines. Together, we will then look in more detail at the 7 experiences of fabric so that you gain a proper appreciation for what exists and how you can use it. To round off this course, I'll be showing you how you can get started using Fabric for yourself and signpost some of my favorite resources for learning Fabric that I think can really help you in your own journey. So if you're wondering, is this course really for me? Should I invest the time to sit through this course? Well, the great thing about Fabric is that it's an end-to-end unified solution, which means that it caters for every data persona in your organization. So if you're working in any of these roles, currently maybe outside of Fabric, then this presentation will definitely be highly relevant and interesting for you. Or if you want to be working in one of these roles within Fabric in the future, then this course will also be a great foundation for you. Either way, no knowledge of Fabric is assumed. There's not going to be any code examples or too technical in the weeds stuff. This is quite a high level course. If you want a more detailed explanation and code examples, feel free to look at my other videos on YouTube where there's lots of that stuff on there. And I'll be using plenty of practical examples throughout to solidify your understanding of the platform. I've spent over 200 hours preparing this course, so I believe it will definitely be worth your while. Recently, I took the DP700 exam.
Are you ready to elevate your skills in data engineering and unlock?
Hey everyone, welcome back. And in this video, I'm going to be talking about stick around, onto analytics, which you're about to see, as built especially notes and links to further resources. It helps to properly understand the problems that Fabric has been built to solve. And to illustrate this, I want to tell you about the story of Houston Electric. Now, Houston Electric is a fictional electrical goods online retailer based in the US, but it ships electrical parts around the world. The company's grown to over 400 employees to service a growing demand. And the company prides itself on being innovative and uses data to make better decisions. In 2015, Houston Electric hired their first chief data officer, who launched a digital transformation program to make better use of technology to drive business growth. Central to this strategy was the establishment of a central data department, now with more than 50 employees. And the company has invested in a number of cloud technologies in Azure and Amazon Web Services, and they've started using Power BI. Looking at what the company is using today, we can see that the company is split into the following main departments, at least from a technical point of view. Each department has a number of data technology data. And if you're not familiar here with all of the logos on the screen, don't worry. The point here is that the data landscape in the company has grown organically over the last 8 years with little strategic vision. This is a common situation that a lot of companies find themselves in. Each department uses the tools they prefer, and each department relies on data from other departments to do their job. For example, the customer success team manages the order reviews database, which keeps track of all the reviews that customers leave about their products. Now let's look at a particular workflow that uses this orders review database to see how it works and see how the company functions. So when a customer purchases a review database to see how it works and see how the company functions. So when a customer purchases a product, they leave a review on the website, and the review data is stored in an Azure SQL database managed by the customer success team. And the data engineering team in the company have built a data pipeline that copies this data every morning into a data lake for data scientists to analyze. And the data scientists then take this review data, they perform sentiment analysis on the reviews, basically to gauge whether the customers are liking or hating certain products based on the text they write. And these sentiments are then written into a data lake container. Finally, the BI team have created a Power BI report that communicates these findings back to the product teams to help them improve the products going forward. Now they've got this workflow to a point where it's working, but it was a pain to set up and it's a pain to maintain. And data just for this one workflow is scattered across 4 different locations in 4 different data formats, some of which are proprietary, meaning you can't really access it very easily from other tools. And this is just one workflow. The company operates many data processing pipelines like this, copying data between different departments and between different storage locations and products. The complexity of the data landscape has grown so much that the maintenance of these existing systems and processes becomes an almost full-time job. So to analyze what might be going wrong here, let's map out some of the tools that the company is currently using under these four broad buckets of data ingestion, data storage, data engineering and data science, and business intelligence. Now let's analyze the current situation against these 9 considerations listed down the left-hand side. And to analyze them, we're going to speak to a number of key employees in the company. So if you speak to the chief data officer, they're going to tell you that the data architecture has grown organically, and now there are data silos all over the place. I'm the chief data officer. I'm on our visual map here, we can plot different blocks that represent all the different systems that create different data silos. Then, if we speak to the data engineering lead, he tells us that we're maintaining hundreds of pipelines, copying data between lots of different data stores for different departments, and it's messy. And to get around all these silos of data within and between departments and data products, the data engineering team have been flat out building data pipelines that copy data from here to there, and now they're in too deep. The pipelines are failing regularly as there's just too much to manage and maintain within a small team. So on our diagram now, we can see all of the different copies between each system and product and how this is causing confusion and maintenance and problems with data quality as well. It's not just the data engineering team this causes issues for. Imagine being a Power BI developer. How on earth would you know which data sets to connect to within an organization? And how can you know if they're up to date and whether you can trust them? The data science team faces similar issues. They mentioned that we have data scattered in so many formats in different places, and it takes me days to get clean data sets just to begin an analysis. And even then, I don't know if I can trust the data. And on top of that, just the fact that so many systems exist and they're all different creates a cognitive overhead for this team. They added that I had to learn the intricacies of many different data technologies, and each one is different. We had a new starter, and it took 3 months to upskill them in all the different data platforms we use. So let's add those problems onto our visual here. The data scientists mentioned that there's no uniformity in data formats across the organization, which makes it difficult to get everything into a common format needed to begin analysis. On top of that, they have to work every day across 5, 6, maybe 7 data products, each with their own learning curve, user interface, user experience, and this is inefficient, especially for new joiners. So the different color blocks here show how the user experience is different in each of the tools the company uses. Next, the IT director is not happy too. He's saying we're using too many systems. All have different security profiles and requirements to keep data at rest and data in transit secure. And it's a nightmare. And it's true. It's not just the people on the front end of these tools that find it difficult. Spare a thought for the IT director and his team responsible for managing access to each of these tools independently, securing them and the data stored within them, governing the data, and then monitoring and maintaining the systems generally. And as if that wasn't bad enough, he also gets the finance director on the phone every month to complain about the Azure bill. He added, "I dread getting our Azure bill every month. It's so unpredictable and sometimes scary. Each data product has their own pricing structure, so it's difficult to predict how much we will be charged month to month." So now we add billing and licensing to our visual here. And we can see that each product has a different licensing and a different port here. There's all of this component. They lose trust in the visualizations and the data being presented to them. Then what's the point in all of this anyway? So let's just pause there for a second. And it was at this point when the head of Houston Electric, the smart guy that he is, was watching the Learn Microsoft Fabric YouTube channel. Wow, what a coincidence. He learned about Microsoft Fabric, and he knew that Microsoft Fabric could help solve the problems that they were experiencing as a business. And he was right. You see, within Microsoft Fabric, we have a family of data products available to us, which loosely fall under the 4 buckets that we were looking at before: data ingestion, storage, data engineering, data science, and business intelligence. Now, these tools, when looked at in isolation, they serve a similar function to the tools that the company was using previously. And it's a common myth that you sometimes hear people say about Microsoft Fabric is that, oh, it's just a remarketing exercise. They've just put a new badge. Because that we saw. Let's look at what we'll explore in more detail a little bit later on. How OneLake eradicates data silos. So data across all these different products is actually stored in one place. And because of this, it also eradicates the need to create multiple copies of a dataset. A fundamental principle in Fabric is that a dataset should only ever exist in one place, and then be referenced throughout Fabric using a clever feature called shortcuts. So all your organization's data is stored in OneLake, and in OneLake, all data is stored in the same format called Delta Parquet. And this is an open standards format. And this solves so many problems that we highlighted previously. Most importantly, it solves the data integration problem. So data scientists, data engineers, and data analysts might all be using different tools, maybe different languages that they're familiar with, but under the hood, they're all working on the same data, which is in the same format. And they're not wasting hours and days trying to get that data into a suitable format so that they can begin their analysis. Next, Fabric provides a unified user experience. We heard previously that people were sick of having to log into multiple different platforms, each with a different look and feel. When in Fabric, you log in via a web portal, and the user experience is designed to feel similar to that of Microsoft 365. So you log in once and you can navigate to any Fabric experience, and each experience has a similar look and feel. This means you can spend more time thinking about how you're going to get value from your data and not worrying about how to navigate through the application. And for people administering Fabric, there's so many benefits too. For starters, access control and security is drastically simplified in Fabric. There's one access control method and one security model applied across all tooling and experiences. And access to these resources is principally managed through workspaces, which is just a collection of Fabric items that makes sense for a particular security boundary that you want to set up. And because all of our data lives in OneLake, data governance and discoverability becomes a much easier task. And in fact, Fabric has many features built in for governing your datasets. Next up is a really important one. Fabric comes with a single built-in monitoring hub, which monitors all Fabric activity across your experiences. So you only have one place to look if you want to monitor all of your different data pipelines, your notebook runs, any kind of processes that you're running within Fabric. And last but not least, billing and licensing in Fabric is unified, meaning that when you purchase some Fabric capacity for your organization, you immediately get access to all of the features and items. There's no longer a separate license or billing structure for all of the different products listed above. Now, there's different levels of capacity you can buy depending on the intensity of your usage. And something to bear in mind here is that if your company is currently paying for Power BI premium capacity, you get an F64 Fabric capacity, which is a lot of capacity in Fabric for free with your Power BI premium capacity. This means you can create and use any Fabric items today without paying any extra. And all of these things that I've mentioned here are kind of a topic within themselves that I could go into a lot more detail on. But what I've done is if you go through to the community link here and go through to the classroom tab, I'll leave a link in the description. There's links to a lot more resources where you can learn about each of these specific features in Fabric in more detail. Okay, so now we're starting to understand the power of Fabric in more detail. Engineering experience, you'll find easy access to tools that a data engineer would use is under the hood, automatically stored in OneLake. And crucially, all the data stored in OneLake is stored in this format, the Delta Parquet format, which is, as I said previously, is an open standards format. So to interact with data in any of these stores, we can write T-SQL scripts in the data warehouse. We can write Python, R, or Scala in the notebooks in data engineering and data science experiences, or we can write KQL in the real-time analytics experience. And there's also a lot of low-code and no-code options for beginners in each of these experiences. And Microsoft Copilot is now tightly integrated into and running quickly in Fabric. Now, once the data is stored in OneLake, it's direct experience that they're currently using. Now, once the data is stored in OneLake, it's directly accessible by all the other engines without needing any import or export. And all the compute engines have been fully optimized to work with Delta Parquet as their native format. As well as data stores and scripting tools, there are more items available, a lot more items available to us in each Fabric experience. So now we have a good understanding of how the overall architecture works. Let's review each experience one by one, starting with Data Factory. So the Data Factory experience in Fabric is primarily focused with Data Factory. So the Data Factory experience in Fabric is primarily focused on moving and transforming your data. And a core use case is using Data Factory to get new data into Fabric, perhaps from an external API or by connecting to one of your organizational systems. You could describe the Data Factory experience as a set of tools to help you with extract, transform, and load functions. Now it's built for enterprise scale too. So if you have a lot of data or a high frequency of refresh, then this shouldn't be a problem. Now the Fabric items that you can create within this experience are the data flow. And the data flow basically allows citizen developers to connect to more than 300 data sources to bring data into Fabric, transform it using a kind of familiar low code, no code Power Query interface. So if you're a Power BI developer or you've used Excel, then this will be very familiar to you. And the data can then be written into one of the Fabric data storage solutions like a Lakehouse or a data warehouse. We also have the data pipeline. Now this is an orchestration tool and it's used to trigger different data processing workflows, normally on a schedule. For example, triggering the run of a Fabric notebook on a particular schedule, or maybe triggering a stored procedure in your data warehouse. And pipelines can be used also to bring data into Fabric. This set of tools provides similar functionality to existing tools that you might be familiar with, like Azure Data Factory, Synapse Pipelines, and Power BI Dataflow Gen 1. And the main personas who might be using the Data Factory tools would be data engineers, analytics engineers, and also Power BI developers. Now the data warehouse experience consists of the data warehouse, unsurprisingly, which provides a familiar transactional data warehouse solution with tables, schemas, views, stored procedures, and all that good stuff. And it's obviously queryable using T-SQL. And it provides features to make it more accessible for citizen analysts. So there's visual scripting, low and no code solutions built into this experience as well. And it's late and a transactional data warehouse can create a similar set of functionality, although not exactly the same to some of these, because the two underlying similar to could be database administrators, data engineers, data analysts, those kind of people. Next up, we have the data engineering experience. And data engineering in Microsoft Fabric enables users to design, build, and maintain infrastructures and systems that enable their organization to collect, store, so Lakehouse tables. And we do that using notebooks and other tools as well. Data, so files, and convert them into structured data, so Lakehouse tables. And we do that using notebooks and other tools as well. But the notebook is where a user can write and run scripts in a variety of languages to perform data engineering tasks like cleaning data or validating your data or whatever you like, really. And the languages available to you are Python or R or Scala. And the notebook is built on top of Apache Spark, which is a big Spark job definition framework. And this is how to execute a bit more control with Milix or Snowflake. And obviously the main personas who might be using the data provides we have the data set of tools to optimize the tracking funds, items, time event data. And event data is a completely different paradigm really in data analytics and requires a different mindset and also a different set of tooling. The Fabric items you can create within logging, then this is the same engine that's data in a KQL data analytics engineer, business intelligence associated some simply, but people who are consuming it's currently in preview. Specific data point that you're tracking that's monitor business users. Before we finish, that's the Microsoft documentation. So links to the analytics as well. I don't us in Fabric, and he documents them really well in a lot of detail. So
I'm sure many of you are interested to get hands-on with Microsoft Fire's APIs. That this work email show you the account, stories and services, but your user I'm using Azure create one. And like I said, you won't be charged. Once you register, you should be taken to the Azure portal. Here's the account that I'm signed into. You can sign in and out of this account. So let's count. Entra ID that you sign a new one. So notice the on Microsoft.com, give the user a name, and it doesn't really matter what the name is, address, then create email, app.fabric with the email. Instructions is now phone numbers, and that should take you to this screen. So there's one more thing to do to enable the trial, and that is to click on this icon here, and then click on Start Trial. You can see here, the trial has begun. So you should now have a 60-day free trial of Microsoft Fabric without needing to use your work email address.
About the bits really within the in detail what OneLake to where for managing into data engineering experience. So in the first half we mentioned a lot about the Lakehouse and some of the tools you can use to interact with it, like the notebook and Spark Def in a few seconds. The description, the other string, read only, Power BI obviously generated. The other point in the description, here you go, easy as that. So let's start off with a bit of a tour. So you can see along the top here we have some settings in that we have, and I'm just going to click here, and the endorsement. Lakehouse are ready. We can create a shortcut, and let's just briefly here just to get a display of the top, I don't know, 1,000 rows in this data set, just to give you an idea of the shape of the data. And then if we wanted to do more stuff on top of that, up a data, you know, we can do all sorts of send your code basically. So here's our data. Another way of querying this data would endpoint, and it can do data, or we have, and it the way of actually really line of transformation. They have stop this session, and we can close this notebook. Let's go back to our Lakehouse. And now I can show you what the SQL endpoint looks like, because we do actually have some data. It looks, you know, we can do all sorts of data. Or so another thing, querying each of these, we want to create a new report. Another area, pipe, to do both. Pandas